Hi, this is Involved Innovation YouTube channel. In this video, we will see about what is 12-factor app in microservice. In the last video, we have seen about the overview of different software architecture and how it compares with each other on different scenarios. If you haven't watched that video, please watch that video before proceeding with this video, the link of which I have provided in the description. Now, if you want to build a microservice, either it can be on-premise or cloud-native microservice, the success of the microservice depends on how well it is architected. A badly architected microservice is worse than a monolithic service. That being said, how we can create a standard and successful microservice? That is where this 12-factor app comes into the picture. This is Heroku Best Practice Guide, which is widely regarded as a standard for developing and deploying microservices, which can be highly scalable and easily maintainable. These 12 best practices provide guidelines for designing, developing, and deploying the microservice. I will cover why we need a particular best practice, what problem this best practice solves, and what are the different anti-patterns. What happens if that particular best practice was not followed, and I will also try to cover the priority of each best practice. These 12 best practices are really good for developing a microservice, but if you are a smaller organization or you are taking gradual transition towards converting your existing monolithic architecture to microservice, then this priority can be used. The 12 factors for designing, developing, and deploying the microservices are Codebase, Dependencies, Config, Backing Services, Build, Run, and Release, Processes, Port Binding, Concurrency, Disposability, Dev Prod Parity, Logs, Admin Process. We will see everything in detail with pictorial representation and scenarios. Codebase. Use version control system to store all your code. This is absolutely mandatory. With version control system, one can track changes, revert to any specific previous version of code, and integrate with CI/CD pipeline seamlessly and more. To learn more about version control system, refer to my video tutorial on importance of version control system, the link of which I have given in the description. A 12-factor app emphasizes on having single code base for each microservice, but there can be multiple deployment to different versions for the same code base. For example, a recipe application must only have one code base, and here the version control tool is Git. The default or main branch in this repository can be used for production deployment, and each release can have a separate branch. And there can be a deployment based on this branch for staging environment, and there can be development deployment based on the develop branch. So one code base for an application can have multiple deploys. Here the anti-patterns are, that is the violation of 12-factor app is having two or more repository for a single application, or using one code base for two different applications. This code base factor is mandatory for building a microservice. Without this compliance, there will be chaos in both deployment and development of the microservice. Dependencies. Dependencies must be explicitly defined in the app code base in a file. Most languages or build framework provides a default way to store the dependencies for the application. For example, in case of Java build tool, Maven has pom.xml and Gradle has build.gradle, where all the jar dependencies for the applications are defined. Node has package.json and Ruby has gem file. Never let your application assume the dependencies will be already available on a given machine or deployment environment. This step is absolute high importance. This dependency file can be used to set up the development environment in the developer's workstation with ease, and this also makes sure the application has the same dependencies across all the deployed environments, thus by eliminating the code works on my machine problem. The dependency file must be a part of the application code base. The anti-pattern for dependencies in the 12-factor app is using a dependencies which is not registered explicitly in the dependency tracking file. For example, in case of Java, adding a jar dependency directly in the class path without adding this in the pom.xml or build.gradle. Since this jar is not registered in the application won't run same in different developer machine and different deployment environment without this particular jar. Next we will see about config. The configuration is the only change for an application between different deployment environment. For example, in case of recipe application, it has recipe database as the backing service. The database configurations like database URL, username and password are different for developer's local machine, development environment and in production environment. Configuration must not be part of application code base as configurations are environment specific, so it must be externalized, consistent and changes need to be tracked and managed at real time. For example, in the recipe application, the configuration must not be part of the code base. Application calls a config server which connects to the config git repository. In the config git repository, there will be configuration for production, development, test and other staging environments. Based on the environment parameter sent by the application, the config server provides the required configuration for that particular environment. Since the configuration files are present in the Git repository, all the changes are trackable and we can get all the benefits of the version control system. The configuration is externalized, not part of the application code base and can be changed or managed at the application runtime. The anti-pattern here is hard coding the config files part of the application code base. And for each change in the configuration, the new build artifact need to be created. If there is a change in the configuration at the application runtime, then the application need to be stopped, a new build artifact need to be created and deployed. And this config file need to be always externalized as part of 12-factor app. Next we will see about backing services. Backing service is any service the application consumes over network as part of its normal operation. Example, here the recipe application uses Redis for caching, Postgres database for persisting the recipe data and also connects with the item API service. Here the Postgres, Redis and the item API service are backing services. In the 12-factor app, there is no distinction between the local or the third-party services. For example, here the recipe application deployed locally uses the local database, Redis deployed in local and items API deployed locally. When the application moves to the production, then it needs to start consuming the Postgres in AWS RDS and AWS MemoriDB for Redis and items API without making any change in the application code base by using the production configuration. By this way, it makes possible to change the backing service in production without making application code change. For example, if the Postgres database is corrupt in production, then the application must be capable of switching database without any modification in the app code base by just changing the configuration at the runtime. Next we will see about build, release and run. There are 3 stages in creating a build artifact and deploying it to any environment from the application code base. They are build stage. In this stage, it converts an application code to an executable bundle or build artifact. Also performs the unit test and integration test on the build artifact. If all the unit test and the integration test succeeds, then the build artifact will be created. Next is release stage. Release stage takes the build produced by the build stage and combines it with the deploy's current config and assigns a unique release ID. Here the unique release ID can be a string build followed by build number and then timestamp. The resulting release contains both the build artifact and the config and is ready for immediate execution in the execution environment. Next stage is run, which runs the application in the execution environment by launching the release produced in the release stage. There are tools available for CI/CD which simplifies this process for release, build and run. In the 12-factor app, there must be a strict separation between these 3 stages: build, release and run. Once the artifact is built, it is impossible to change the code in the current artifact. In other words, the build artifact is immutable, which happens independent of other 2 steps. If these steps are independent, then it is possible to release any build with config and can run any release in the deploy environment. For example, if there is a problem in the current production release, if these steps are independent, then it is possible to run the previous release easily. If these steps are not independent, then all the steps need to be started again, that is from build. There might be a scenario where a build need to be triggered from the old version of code. This is very prone to error and time consuming. Next we will see about 12-factor app processes. The application must be executed as one or more stateless process. That is, a 12-factor application must be stateless, and if any data needs to be persisted, then it must be done in database or in caching data store. For example, user starts creating new recipe and the user started adding ingredients to the recipe, and we are doing server-side caching directly in the server cache. Let's take if the server which the user communicating with crashes, all the data user cached till now will be lost. If the request sent to the new instance by the load balancer, then the user will get error and they need to start from beginning. This will give a bad user experience. This problem can be solved if the application behaves stateless, that is, no information is stored on the server directly in memory cache. Instead, this data can be stored in the external caching data store like Redis or memcached. If any of the server instance stopped working, then the request can be seamlessly forwarded to other instance since the cache is stored separately. So the 12-factor app emphasizes on application must be executed as one or more stateless processes. Next is port binding. Web application need a web server to run. A 12-factor app emphasizes on having this server added to the application as the dependency, and port for this server to run must be provided in the config file. For example, if you are creating a Spring Boot application and creating an executable jar as a build artifact, this Spring Boot jar comes with the embedded Tomcat, so the build artifact can start by itself and we can dedicate a port for this embedded Tomcat server to run with the external config file, so that this application can be completely self-contained and does not rely on runtime injection of a web server into the execution environment to create a web-facing application. So for a 12-factor app, it is mandatory to add a server as a dependency to the build artifact, and the port for the server can be directly provided from the config file. Next we will see about concurrency. All the modern web application must able to withstand any amount of request or load. A 12-factor application should scale out using the process model. Let's see this with an example. Let's take the calorie counter application. You have all the three essential backend services, recipe, item and user API service deployed in a bigger instance. And now the application need to be scaled out because of its increasing popularity. There are more requests. Now the machine size is increased. Let's take you are using AWS EC2 instances. Upgrading from T2 small to T2 medium with 2 CPU and 4 GB RAM. If the request increases further, you need to upgrade to L2 large with 2 CPU and 8 GB RAM. If still not sufficient, then you need to upgrade to the next big instance T2X large with 4 CPU and 16 GB RAM. This is vertical scaling. Eventually we will hit a point where the single instance can't be upgraded beyond the maximum available size. So the 12-factor application emphasizes on scaling out the application using process model. This can be achieved by using the containers with horizontal scaling. Let's take the user API, item API and recipe API running one container each. Now the application need to be scaled out, so the number of containers for each API are increased to 2. Under investigation, we found the user API gets lots of requests compared to the recipe and the item API. With the horizontal scaling, we can scale out the user API to 4 containers, and with container we can effectively use the underlying system resources. Here the user API uses 4 containers, recipe and the item API uses 2 containers. So each service can be individually scaled. With the auto scaling and various other container orchestration framework, it is easy to scale up or down the application based on the load at any point in time. The key for concurrency depends on the 12-factor processes which we have seen earlier. That is, the application must be executed as one or more stateless process. If the application is executed as one or more stateless process, then it is very easy to scale out horizontally. So the 12-factor application emphasizes on scaling out the application using the process model. Next we will see about disposability. We have seen as per 12-factor concurrency, the application need to be scaled out using the process model, that is, the application need to be horizontally scaled out. 12-factor application must have fast startup and graceful shutdown. As per the process model, the processes or the containers are disposable, that is, they can be started or stopped at a very short notice. This helps in auto scaling during the peak hours of the application. Server instances must start up with very minimum startup time and shut down gracefully. For example, let's take the recipe application. When the start command is issued, the container must start up immediately. Container have the advantage here compared to the virtual machine because container has less startup time, and when the stop command is issued, the container must shut down gracefully. That is, first it must stop listening to the port so that it won't receive any new request and process all the requests which are currently processed by that container, and then need to log the necessary logs that this container is shutting off. Then the container need to be shut off. This is very essential if your application have a global presence and has a variable traffic. 12-factor app emphasizes on application need to be having a fast startup and graceful shutdown. Next we will see about dev or prod parity. The 12-factor application emphasizes on having development, staging and production environment as similar as possible. First we will see about time to ship a change to the production. This is how a traditional application looks like. First the user commits a change to the application code repository. This triggers the CI/CD pipeline which runs all the unit test, integration test and creates a build artifact which then released by combining this artifact with the development environment config. Then release will be deployed and run in development environment. Once the test team says OK, then the changes will be released to the production after weeks or even months. 12-factor application emphasizes on having a small time gap between the development to production deployment like hours or days, thus by keeping the development and production branches of code as similar as possible. Next is development and deployment personnel. In traditional application, the application will be developed by a developer and DevOps person is responsible for deploying and taking this code changes to the production. A 12-factor application emphasizes on developer taking the responsibility to develop as well as taking those changes to the production and monitoring this application behavior in the production with the monitoring tools. Next, and the very important one, is tool difference between the environment. In traditional system, a developer's operating system can be Windows and the developer is using H2 database which is lightweight and using in-memory caching, whereas the production environment's operating system is Linux and the database in production is Postgres and for caching Redis. There is a substantial difference between the production and the developer machine. This may result in unexpected issue in the production environment which might be working fine in the developer machine. A 12-factor application emphasizes on using the same tool in all the environment. This difference can be removed with the advent of containers. With the help of containers, developer can spin up a container for the application, another for the Postgres database, another for the Redis with a simple Docker Compose file. And the same configuration can be used in production, thus by removing the tool difference between the different environment and eradicating this code works in my local problem. Summary of the dev prod parity in 12-factor application is reducing the time difference between the development and production deployment, developers handling responsibility in developing and deploying the application and then monitoring the application in production, and removing the difference in the tools between the development and the production environment. Next we will see about 12-factor app logs. Logs are very essential for monitoring and debugging the issues of the deployed application. In traditional server-based environments, the application writes log as a file on a disk. In the developer's local machine, logs will be displayed as a stream of data in the console. Logs are the stream of time-ordered events collected from the output stream of all running application and backing services. Logs in the raw form are typically a text format with one event per line, which contains timestamp, log level, and log message. Logs have no fixed beginning or end, but flow continuously as long as the application is running. A 12-factor app never concerns itself with routing or storage of its output log stream. Each running application writes its event stream unbuffered to the standard output. Here we have a recipe application, user application, item application produce its stream of logs, which will be consumed by data processing pipeline such as Logstash that ingests data from a multitude of application sources. The event for an application can be sent to log indexing and analysis systems such as Elasticsearch, which can be used by systems like Kibana to visualize the data. A microservice application should never be concerned about the mechanisms of how this happens, like routing or storage of this log stream. Next we will see about admin processes. run admin or management task as one-off processes. Developers may often want to do some process which will be performed only once before deploying application to any particular environment. For example, running data migration scripts or running script to inspect backing services, for example, database script or caching script to analyze the existing data in the production or in any other environment. This script must never be done ad hoc. Instead, it must be done via a script file which will be stored in the source code repository. This script must be common for all the environments. This script must be executed before the application starts. This script must be executed from an environment which is identical to the production environment, which has the same release code base which is present in the production. This code must ship with application code to avoid synchronization issues. It is better to make the script execution as part of the automated process so that it does not need to be executed manually on all server instances and it is identical across the environment. So, a 12-factor app emphasizes on running the admin processes task as one-off process. Here in this video, we have seen what is 12-factor app and how we can improve our microservice architecture with these 12 factors. A 12-factor app principles are designed to allow developers to create applications that can be easily scalable, upgradable, and maintainable. If you are a smaller organization or are converting a larger monolithic service, then this 12-factor app might be seemingly overwhelming at the beginning. So you can implement this 12-factor app gradually, like implementing which your development team feels essential and gradually implementing all the 12 factors. By that way, you can implement all the 12 factors slowly to your system. Thanks for watching this video. If you found this video helpful, then subscribe to this channel. Subscribing to this channel motivates me to put more videos.